Okay, so 4-4, we're looking at trig functions, different angles. Um, we just want to make sure one of the things that we do is know where things are positive or negative. So if we take this xy axis and I draw a quick triangle in the first quadrant, we know that the hypotenuse is always positive when solving the quadratic formula. Going to the right is positive and going up is positive. And since all three sides are positive, all trig functions will be positive. So now if I do the same thing in the second quadrant, draw a triangle, the right triangle in the second quadrant, again, the hypotenuse is positive, going up is positive, but this time going to the left is negative. And if we think theta should be in the corner here. So if I put theta in the corner, in that angle, using the different sides, opposite over hypotenuse, using the opposite side and the hypotenuse side will give me a positive angle, and that's sine. If you look at the other angles, like opposite and adjacent, or adjacent and hypotenuse, they use that negative side, so then you're going to have negatives. So what we're trying to do here with this setup is find when things are positive. So now when I go to the third quadrant, get my theta in there this time, going left is negative, going down is negative, but the hypotenuse stays positive. So now this one, if you take the opposite and hypotenuse, you're using a negative side and a positive hypotenuse. If you use the adjacent, you'd be using negative and positive. And so the only one that's actually positive is tangent. And that's because tangent will use the opposite and the adjacent. So technically what's happening is you have the double negative. So that's why tangent is positive. And then in the fourth quadrant, again, you have right angle, theta, but this is positive going to the right, hypotenuse is positive, and going down. And so this one is cosine. Cosine uses the adjacent side and the hypotenuse. And then, of course, we get their trig reciprocals. So you want to memorize this. All of them are positive in the first quadrant: sine, tangent, cosine, and the reciprocal partners. So let's practice this. On an example like this, I'm going left 3 and up 4. So I'm going to end up somewhere up here. So we come out from the origin, go vertically to the x-axis, and put theta touching the terminal side and the x-axis. So then this was -3, this is 4. You can do the Pythagorean theorem. -3 squared is 9, 4 squared is 16, add them up is 25, square root of 25 is 5. So now when I do my trig functions, sine, cosine, and tangent, sine is opposite 4 over hypotenuse 5. Cosine is adjacent 3 over hypotenuse 5. And tangent would be opposite over adjacent. So opposite over adjacent. I'm just going to put the negative on the side. So you can see that the only one that's positive is sine, because we're in the second quadrant. And then when we do the reciprocals, cosecant, secant, and cotangent, this is 5/4, this is -5/3, and this is -3/4. And so again, the only one that's positive is cosecant, because that's the reciprocal of sine. So on So now on an example like this, we kind of want to, they're giving us two clues in the problem. One, they're telling me that cosine is equal to 2/3. What that's also telling me is that cosine is positive. So what I would do is I would put a check mark where cosine is positive. Well, if we look at the all seniors turn crazy, is how we kind of remember it. All seniors turn crazy. All seniors take calculus. All trig functions are positive there, and cosine is positive again down there. Now the second clue that they're giving us is that tangent is less than 0. What that means is that tangent is negative. Well, tangent is positive in 1 and 3. So it must be negative here and here. And so what I know now is that I'm going to draw a triangle in the fourth quadrant where the double check mark, the overlap happens. And so now I draw my right triangle, and then I go cosine. So cosine is adjacent to hypotenuse 3. So if I do the Pythagorean theorem, I would go x squared plus 2 squared is equal to 3 squared. So I will subtract 4 on both sides, and I get x squared is equal to 9 minus 4 is 5, and my x turns out to be the square root of 5. Now watch this. So when I put square root of 5 in, I have to make sure that in the diagram that's going down. So even though it was a positive number, because the Pythagorean theorem will give me positive numbers, I have to put negative on that. So the square root of 5 becomes negative because it's going down. It's the down direction. So the last thing they ask us to find is what is cosecant. Now cosecant is the reciprocal of sine. So cosecant of theta would be, instead of opposite over hypotenuse like sine, it's hypotenuse over opposite. Then you have to rationalize it, and you get a negative 3 root 5 over 5. All right, so the next one is a DIY. Try to put check marks in the where they give you the clues. And this one, actually, they just tell you let theta be in quadrant 3, so you don't have to worry about it. But find secant and tangent. Pause the video now. All right, so you drew a triangle in quadrant 3. You labeled it with the -5 and the 13. Definitely the negative goes here because it's going downward. And you can find the missing side is 12. But when you go to put 12 in here, you should make sure that you make it negative because it's going left. And then you can do the secant, and you get 13 over 12, negative also. Tangent, the 5 over 12. So hopefully those are the answers that you got. All right, reference angle. Simply, reference angle is the acute angle formed with the horizontal axis. So if I draw a diagram, and I think when you do these problems, you should get in the habit of drawing them. They want me to draw 345 degrees. So 345 would be somewhere right about there. So that's my terminal side, and I'm using the arc to kind of show you that I wrapped around in a positive direction to 345. This is the angle that they're talking about. The reference, what is that reference angle? And so I can take 360, which is the x-axis of that quadrant, minus the 345, and I'm getting 15 degrees. Same thing would happen here. I'd wrap around to where 5 pi over 6 is. That'd be here, and I'd have a terminal side coming out. They want to know what is this angle touching the x-axis. So the acute angle formed with the terminal side and the x-axis. Well, that one, I didn't quite make it. Remember, this is 180 degrees over here. And 5 pi over 6 is the same as 150 degrees. So if you didn't make it to 180, you were 30 degrees short, or pi over 6 is the reference angle. So try the DIY, and let's see what you come up with. Hopefully you drew your angle, negative 135 degrees, in the down and around first. So I'll put us into the third quadrant. And the angle that we want is this one right in here. This would be our reference angle. Let's just call it theta. And so the space between that then would be 45 degrees. So remember, this would be 180 in the negative direction, but we're 45 degrees. Now, we don't put a negative or anything on that. It's just 45 degrees. So the next one is 2.5 radians. So I guess we could approximate this. So we draw xy axis. Remember, if we do approximate radians, this is 6, 0 or 6.28. This is about 1.57. This would be about 3.14, and this would be about 4.71. Just approximating, pi is 3.14, and you can get those labeled. Well, 2.5 would be somewhere over here. So if this is 2.5, again, the reference angle would sit between the x-axis and the terminal side. So how far is it from 2.5 to 3.14? It's about 0.64 radians. Now in this one, 580 degrees, we're going to wrap around 360. Another 90 would be 450. 540, right? So then my terminal side would be about right there. So I need to know how far beyond the 540 we are. So 360 all the way around, an additional 180 degrees would put me on the negative x-axis. But I went a little bit further. Well, how much further did I go? 40 degrees. So the reference angle sitting there would be 40 degrees. All right, you try the last one. It's a radian. It's more than 2 pi, so you're wrapping around the circle a little bit more. Figure out what quadrant you're in, and then find the reference angle. So pause the video now. So just looking back at this one, some people take away the 360 and left with 220. So you can just wrap around 180 and 40 more to get it done that way too. If you take 2 pi away from this, so 8 pi over 3, you go around 2 pi, then you'd have a little bit left over, so 6 pi over 3, so you end up with 2 pi over 3 left over. And again, you can do that on your calculator, 8/3 minus 2, then put the pi back in there. You're going to have 2/3 left over, so that's what is our 120 degree angle, or 2 pi over 3. And so then what's pi minus 2 pi over 3? And that's how I got pi over 3. Okay, the next set of problems, excuse me, we're supposed to find two approximate values between 0 and 360 for the given decimal. So the first thing we have to do is get theta by itself. So we're going to do cosine inverse on both sides, and we'll figure out what theta is. So I go to my calculator. I want to be in degree mode. I want my answers coming back to me in degrees. And I simply type in second cosine of the 0.6820 0. Now if you round that up, that's about 47 degrees. So 47 degrees would put me here in the first quadrant. Oops. So 47 degrees puts me here in the first quadrant. And the second one would be located where cosine is also positive, because when you look at this, cosine of theta is producing positive answers. Well, that'll also happen down here in the fourth quadrant. So I need to know, wrap all the way around, I need to know that big purple angle that starts at 0 and goes all the way around to the fourth quadrant. Well, we use the idea of reference angle, so I'm going to take that reference angle of 47 and also put it down here. And so I can take 360 minus 47, and that will give me 313. So there are my two answers. So now just to show you how it works, I can come back over here. And if I take the cosine of 47, that's pretty close to the 0.6820. I got 0.68199. So if you round that up, it'll be close to the 0.6820. And if I do the cosine of 313, it also is very, very close to the 0.6820. So those two decimals are coming back. So that's how these problems work. So let's do it again. This time, when I start the problem, I'm going to look, and they're telling me that the sign here is negative. So sign is positive in quadrants 1 and 2. So we'll be looking at finding answers in 3 and 4. Where is sign negative? Down in 3 and 4. So inverse sine both sides. So second sine of that decimal, negative 0.788. If you want to type in the 0, you can. And I'm getting negative 52. Now, negative 52 is down here in the fourth quadrant. So down in the fourth quadrant. So that's where negative 52 is located. The only thing we have to be careful about is the original rule said keep your answer between 0 and 360. So let's go ahead and add 360 to it. So add 360, and that brings me back to 308. So instead of negative 52, I'm going to call it 308. That's between 0 and 360. Now, the second place where this is supposed to happen is in the third quadrant. So I'm going to draw an angle around from 0 somewhere into the third quadrant. And then what we'll do is we'll put that negative 52 in this corner. That's negative 52. So that's, or just 52. It doesn't really matter that it's negative. Maybe I should not. We'll just call it 52. It's a reference angle, so 52 degrees there. So if you follow the purple, wrap it around from 0 all the way there, it's 180 plus 52. So 180 plus 52, right? And that's where my 232 comes from. So the two answers we got were 308 and 232. So there's a, oh, sorry, did it again. So 232 is the answer here all the way around. So those are your two answers. Now you have two DIYs. So identify where the quadrants are that you'll find these answers. For instance, this one is when is tangent positive, and this one is where is tangent negative. So do little check marks. That'll help you know where you're going to find answers. And then let's see how you do. So pause the video now.